Okay, this is a measurement of intersecting chords proof or demonstration. And what we need to realise is, and we're going to prove that as a first section, is when you have two chords crossing, what you're actually creating are two similar triangles. So we've got X and B is similar to triangle X AM. Okay. And the justifications we can make for this are, first of all, by vertically opposite angles. We've got NX at B is equal to the angle AXM. So these two angles are equal by vertically opposite angles. By the alternate segment theorem, if I put that in, M to B, so angle at A and angle at N in the same segment theorem, are equal, so angles in the same segment are equal, and we can now say that angle MAB equals angle MNB, and that means we've got two equal angles in two triangles. You can either do it by going back to the other chord and saying these two are equal, or by angles in the triangle, but this is enough to say, hence they are similar triangles. Now, one property of similar triangles that we need to consider is the lengths. And you need to work out which sides are the same. So let's just mark in the angles that are the same. So this angle is 1. I'll call it alpha and alpha. And the angle below I'll call B and beta. And beta. We don't actually need these two angles, but the angles between the, actually let's put in a gamma and a gamma. So the sides that join equal angles are also in relationship to each other. So we have a scale factor. Doesn't need to be worked out, but the scale factor for these diagrams, F, is the ratio between sides that are similar. So joining gamma to alpha is xn, and that is paired with xa. So that's a pair that are equivalent to each other, or similar sides. Vertical pairs. So do the other pair. We've got xm, xb first. xb first, and then that is xm. So this side is in the same scale factor to that side. Okay, I've got the same small ones on top. So this actually gives us a relationship between these sides. And the bizarre thing with those is, if I just focus on this, we actually get the side AX times XB, or BX, is equal to the side NX times MX. And what that says is, if I multiply along the chord the total length, this is chord AB, NM, and that's chord AB. The two parts that the chord is split into, when multiplied together, must be constant. And that's the first proof that we need. We'll do a couple of exam questions with it in another video. We've got a second diagram, and doesn't exactly look like the same thing to start with, but it does actually follow the same rule. The key thing to remember though is when we're talking about AX, we're talking about the full length of this side now, and BX is the short length, and the full length of this side and this short side. So this still actually works for this. The reason it still works is realizing the angles using properties of cyclic quadrilaterals. We get a crossover on the angle. So if I say this is angle alpha, we've got 180 minus alpha. Cyclic quadrilateral across the chord, BM, says that the opposite side must be 180 minus this side. So this angle is angle alpha. And you can do the same thing going the other way. Put in beta, 180 minus beta, so this angle is beta. So we've now got similar triangles again, with the same length sides, and we need to find the same scaling. So this must be the parts connecting to x. They must contain the x part of each equation. Okay, so this still holds, and it's by having these same equations. Okay. So we must always go to the x part.